I want to say the thing that nobody really wants to say because it's kind of ruining AI voice agents right now. Stop using n8n agents in your voice agent stack. And I'm not saying stop using n8n. n8n is great. I'm just saying stop using an n8n agent when you already have an agent on the VAPI end that does all of the work for you. Because that's how you end up with an agent that looks good in a demo, but if you try to shift that to production, it's not going to work, and I'll explain why. So I keep seeing a lot of YouTube tutorials teaching voice agent builds that are using n8n agents as the main decision maker on the back end. The problem with a setup like that is that it's great for a demo, it can work, but if you try and put that into a production grade system or you're trying to sell that to a client, when you actually get real users speaking to it, you're going to run into a bunch of issues. So let's make this super clear. VAPI is already the agent. It's already doing the conversation state, the tool calling, the reasoning and the dialogue policy, the turn taking, and handling any ambiguity that comes through with customers on voice agents. So the backend shouldn't then be another brain on top of that. The backend should really be hard-coded business logic. So the way to think about this is that VAPI has the LLM as the brain, it decides what to do, and then the backend is just the tools that it uses to do that thing. So here's the problem if you have an agent inside n8n as well as VAPI. Number one, you get these agent-on-agent conflicts. When VAPI asks for a tool, you want it to be kind of like a vending machine. So you want predictable inputs and predictable outputs. But if your n8n tool is an agent itself, then it adds this whole nother layer of unpredictability. You've got a whole nother LLM that is open to hallucination, unpredictability, variance in the way it answers, and so you're not going to get a predictable output from the tool that you're calling. So that's when you get this weird behavior like hallucinations or double confirmations. Plus, this is so much worse in voice AI because that sort of added latency with the confusion sounds so much worse when it's over the phone. The second reason this doesn't work in production is that we want to prioritize reliability and not cleverness or quick setup. So I would much rather spend a lot more time building out the backend in a quote hard-coded way than quickly set it up with an AI agent. Building out the hard-coded backend process, it takes a lot more time, it's a lot harder, there's a lot more friction, but if you're really going to be putting these systems into production, that's the way it really should be. The third reason you shouldn't use n8n agents within your voice agent system is that debugging becomes really, really hard. Something you've probably heard about is that large language models are kind of like a black box, so observability is a big problem. So when something goes wrong with an LLM, it's pretty tricky to figure out exactly what happened. So if you've got one agent on the VAPI side and now you have another agent in n8n and something goes wrong, it's a lot harder to figure out what happened. Whereas if you have the agent on the VAPI side and then the backend is just hard-coded plumbing, then it's really easy to decipher what went wrong. You can figure out whether it was a problem with the VAPI prompt or whether there's a problem with your workflow in n8n. The fourth reason this doesn't work is because latency stacks up fast. So in voice AI, obviously latency is super important. You don't want the user to be waiting for like 2 to 3 seconds on the other end of the phone after every single turn. And a big source of latency is the large language model. So if you have the LLM on the VAPI side, but now you have to run it through an LLM on n8n as well every single turn, it's just stacking the latency and you're going to have conversations that sound really unnatural and you're going to leave the user with these long periods of silence where they're asking like, hello, is anyone there? And it just doesn't sound good. So here's what you should be really doing instead, or what I would recommend personally. Like I've kind of said already, you want VAPI to be the brain and you want the backend to just be hard-coded tools. So in VAPI, you define the tools really strictly and really concisely and cleanly, and then you build out these tools in their own isolated branches, and then VAPI just needs to choose when to use them and what information to send over to the tools. Everything else is predictable input and predictable output. So I want to give you a little bit of an example of what this might look like. Now, forgive the complicated nature of this example, okay? This is just an agent that I was working on previously, okay? But you can see that instead of an agent deciding the tools to use and the input and the output, we just basically got a switch node here. And so if I click inside of this, what you'll see is that we're basically matching tool call names with the tools and the branches that we want it to go down. So, for example, if the VAPI agent has decided it needs to call the check availability tool, then it's going to come through this node and it's going to see that the tool call name in the webhook data matches up with check availability, and then it's going to go down that specific branch. And then after this, everything else is like hard coded. So there's no LLM step here where it can decide to do something wacky and weird, which, you know, if you've used LLMs at all, you'll know that that definitely happens. So this way, all the agent needs to do is focus on the conversation, and it just needs to know when to call each tool. And so we instruct it really clearly in the VAPI side of when it needs to call what tool. And then once that's done, it basically just needs to wait for the response back, and then it continue with the conversation as we instruct it to. So there's really no need for an extra LLM step in n8n ever. All you need is to just build out these flows step by step in a more hard-coded way like I've done here. And yes, it takes a bit more work. Yes, this does look a lot more complicated than just having one agent with a few different flows coming off of it. But in production, this is what it needs to be like. If you have an agent inside n8n and you're trying to sell that to clients, you're going to fail. I'm telling you, like, don't do that. Now, I just want to briefly touch on why you probably see the style of having an agent inside n8n for voice agent builds on YouTube specifically. So if you've had a look at how to build voice agents on YouTube, you'll probably have noticed the same thing as me, in that a lot of people are pushing the agent within n8n as the way to build these voice agent systems. I think the reason that is because as YouTube creators, the incentive is to come up with a video that's nice and quick, that's digestible for someone who's just getting into the space or a beginner, and that it works for a demo. And the agent within n8n is perfect for that. It's really easy to set up. It can work for a quick demo, and it's really digestible for an audience of, say, beginners, which, you know, realistically, most people who are looking into the space of voice AI are just starting out. So I think a lot of people that end up wanting to take voice AI agents more seriously, they end up with this idea that their architecture of their voice agents needs to be based on having an agent within n8n, and I think that's completely wrong. Now, if you're just building voice agents for fun or for your own little use case, you know, that's absolutely fine. You can use agents within n8n, you know, do what you want, really. But if you are going to sell it to businesses, then you need to kind of step it up a notch in terms of reliability and robustness. And so that's why I'd recommend taking the approach, which is a bit harder, of kind of hard coding the backend like I showed you. So to recap this short video, the key takeaways here are: keep VAPI as the brain, as the main LLM. Don't add any extra LLM steps for no reason. Keep n8n as the backend, hard-coded plumbing side of things. And I promise you, your agents are going to be a lot faster, a lot more reliable, and a lot more robust, and you'd actually be able to build production-ready systems. So I hope that video was valuable, or at least interesting. If it was, hit the subscribe button, and I'll see you guys in the next one.